All right, this is section 4-2, Triangle Congruence by SSS and SAS. So if you recall from the previous section, we want to prove triangles are congruent. We have to prove all 6 parts of the triangle are congruent to all 6 parts of the triangle of another triangle. So 3 angles and 3 sides. In this section, we're going to kind of start learning that we may not actually need all 6 pieces of information. So let's start off with vocabulary review. So here's a diagram, triangle ABC. So which angle is included between AB and CA? That would be angle A. Which side is between angle A and angle C? Well, that would be side AC. What's the included angle, or the angle between side BC and side CA? Well, that would be angle C. What's the included side between B and C? Well, that would be line segment BC. What's the included angle between line segment BC and line segment AB? That would be angle B. And what's the included side between angle B and angle A? That would be line segment AB. All right, vocabulary. So what's a postulate? A postulate is a statement that is accepted as true without proving it. So in geometry, you will use what you know to be true to prove new things true. The statements that you accept as true without proof are called postulates, or sometimes referred to as axioms. All right, so underline the correct word to complete the sentence. You can use properties, postulates, and previously proven theorems as reasons in a proof. So what is a postulate? A postulate is a statement accepted as true without being proved. Item C. Okay, so our first main postulate here, 4-1, we're going to accept this without having to be proved true, is called the side-side-side postulate, or also referred to as SSS. And what this states is, if I know that 3 sides of one triangle are congruent to 3 sides of another triangle, then I know the 2 triangles must be congruent. So if I know line segment AB is congruent to line segment DE, line segment BC is congruent to line segment EF, and line segment AC is congruent to line segment DF, then triangle ABC must be congruent to triangle DEF. And notice the way I wrote that. It has to be in that order. Order matters. Okay, so problem number 1. So I am given that line segment BC is congruent to line segment BF. Notice the marks. Line segment CD is congruent to line segment FD. Notice the 2 marks. We want to prove the top triangle is congruent to the bottom triangle. I know 2 pairs of sides that are congruent. What else do I need to know to prove by using SSS? Well, I have 2 sides. I need a 3rd side. So I need a 3rd pair of congruent sides. So the triangles actually share a common side, side BD. So let's complete the steps of this proof. All right, we know side BC is congruent to side BF. That's given. We also know CD is congruent to FD. That was also given. And we know BD is congruent to itself. That's the reflexive property of congruence. So look at this. Side, side, side. I have now proved triangle BCD is congruent to triangle BFD by side, side, side. And there is your proof. All right, similar postulate is called the side angle side postulate, or SAS for short. And it states that if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So notice what we have here. Triangle DEF must be congruent to triangle TRS by SAS, and triangle ABC must be congruent to triangle FED by SSS. Notice the order of the letters that matters. Okay. So let's try making a proof here with SAS or something like it. So here we go. We want to prove triangle LEB, so this top triangle, is congruent to BNL, the bottom triangle. Circle the angles that are marked congruent in the diagram. So angle ELB is congruent to angle NBL. Circle the sides that form the angles that are marked congruent on the triangle. So segment BL, BN, LB, and LE. Well, we know LB is congruent to itself. We know angle BLE is congruent to angle LBN. Okay, so proving triangle LEB is congruent to triangle BNL by SAS requires two pairs of congruent sides and one pair of congruent angles. The diagram shows congruencies of one pair of congruent sides and one pair of congruent angles. So to prove the triangle is congruent by SAS, we still need one pair of congruent sides and 0 pairs of congruent angles. To prove the two triangles congruent, I actually need to prove NB, segment NB, is congruent to segment EL. Okay. So what would I use to prove these two triangles congruent, SSS or SAS? All right, I would use SSS if I have 3 pairs of sides congruent. I would use SAS if I have 2 pairs and the included angle congruent. So the diagram shows the congruence of all 3 sides. Is that true or false? Well, that's true. In the triangle on the left, the marked angle is the included angle of the side with 2 marks and the side with 3 marks. Is that true? Yeah. In the triangle on the right, the marked angle is the included angle of the side with 2 marks and the side with 3 marks. Well, that's false. The included angles 1 and 2. So, can I use SSS or SAS? Well, I would have to use SSS. I can't use SAS. So, you can't use SAS because the included angles aren't between congruent sides. Okay? So, your friend thinks that the triangles below are congruent by SAS. Is your friend correct? Well, let's check. Are 2 pairs of corresponding sides congruent? Yes. Is there a pair of congruent angles? Yes. All right. Are the congruent angles the included angles between those corresponding congruent sides? No. So are the triangles congruent by SAS? The answer would be no, they are not. Okay, they cannot be proven congruent by SAS because the congruent angles are not included angles. And that is it for section 4-2.